Hello and welcome to the Gen AI series. So in the last video, we learned how we can make a simple agent and use a dynamic prompt middleware to give it some more RAG-based context. So what we did was we just created a simple agent and we were asking it some questions that were based on specifically our own data, to be specific data in this txt file, and we wanted that the agent should be able to answer questions based on this data. But we actually jumped a little bit ahead of ourselves because we haven't yet even learned what an agent actually is. What is a difference between this create agent, what is this doing, which is different from what we learned before in the first video, where we just created a simple LLM chain, where we gave it a prompt, we gave that prompt to a LLM, and we also created an output parser, which would just pass the output from the LLM, maybe created to JSON or anything that we needed. So in the last video, we used a concept called middlewares to be able to give dynamic prompt to our agent. But before getting to middleware, in this video, we are first actually going to learn what agents are and how to create our own agents. So for that, as you might see, this time in this video, we haven't opened our code in VS Code. Instead, we have opened it in Cursor. So anybody from software development background might have already heard about IDEs like this, Windsurf, Cursor, etc., which are agentic IDEs, and you can just over here, as you can see, I have selected the agent mode and I can just give it some prompt and it will do all the changes for me. So I thought, what better way to explain about agents than seeing the actual one in action. So what we'll do is, as you can see, I have created a file over here called whatineed.md. So in this file, I have written a description of a Python program, that I need a Python program that can first print the first n digits of pi, and it should print the first 4 digits as a default. So what I'll do is, in this agentic so in this text box over here, the prompt for the agent, I'll tell the agent to create a Python program. Make a Python program for me called, let's call this py.py, which, and the requirements for what the program should do is in the file. We can just go over here, copy its relative path, and we can just give the relative path to this. So now, as you can see, what we are doing is we are just giving it a very vague prompt. We are telling it that we want to create a Python program and we want that program file to be called py.py. And what this file should do, what this program should do, we are not even going to tell this agent in this prompt. We'll tell it that we have already written what we want in this file. So now this agent, when we give it the prompt, will itself read the file, plan what it needs to do, and create the program that what we are asking it. So first of all, let's just see what more options we have available over here. We can also upload an image, we can tell it to connect to a browser, we can add a lot of context, and there are a lot of different options for which model to choose. So agent also has a LLM model at its core as a reasoning component of its main architecture. We are going to learn about the architecture of an agent in just a bit, but let's just see it in action. So I have selected the model Sonnet 4.5. So it's from Claude. There are a lot more models, but let's just choose a little bit cheaper one. So now let's just give this the prompt. Let's not waste more time. So as you can see, the agent is planning the moves it needs to do. And now it says that, okay, it will help me create this Python file, and it needs to first understand the requirements. So it automatically read this file, and as you can see over here, the py.py file got created automatically. And it is also reading that Okay, it also says that it needs to run this file but we can just say we want to skip this. We don't want to, um, we don't want the agent to do the testing and all for now. And we can review the changes as well. So we can like see what this agent did, and then we can undo or keep the changes. So we'll decide to keep the changes, and we can just go over here and see this is the file it created. And if we run this file, the first four digits of pi are 3.14. So it does not print the point, but it did a pretty decent job. So it is printing the actual digits of pi. So like let's say I make this 10 and then rerun it. So now it's printing the first 10 digits. So I'll have to actually check the program to see if it's correct logically, but as you can see, it did make a program to print the digits of pi. So now this is nothing new. A lot of you might have already used cursor at some point or something similar. But today we are going to learn that how we can create a cursor type of a system of our own. So, but before diving into the coding, let's also dive into a little bit of what a agent actually is. So we know that, okay, when a user is there and it gives a prompt, just like we gave. So let's say we give it a prompt that make a Python program, and let's say we give this prompt to a simple LLM. So now this LLM cannot actually make a Python program for us, right? It can only give us a text-based response back to us saying that, okay, the Python program, it might give us the code and then we'll just have to copy this code ourselves and put this into some file, some .py file, and then that code, then we'll be able to run that code. But we don't want that, right? We want something like cursor, where we can just give it a simple prompt and it does everything end to end for us. So in an agent, what happens is an agent is a little more complex system compared to just a LLM, but it also uses LLM. So agent also has a LLM. The LLM can be any model. As we just saw in the cursor, we had a lot of options for the LLM models. So it also has a LLM which is responsible for the actual decision making and creating the code and all. But with this, the agent also has some tools. So tools. So we'll see what tools are in just a bit. But first let's continue. So it also has some tools. It has state. So it not only, so it has a state so that it can remember what it's currently doing, and finally it also has an execution loop. So agent has a lot of components. So this is an agent, and what happens is, so whenever a user gives the agent a prompt like make a Python program, what the agent does is, first of all, like let's say like in the previous example where we added rag to our agent, we could also add rag to this agent as well. So we'll just retrieve some additional context from, let's say, a vector store, which we have over here, a vector store, and then we give the context as well. But for this video, let's just ignore all the rag part for now. We'll just focus on what an agent actually is. So when we give it a prompt like this, the agent first gives this prompt to a LLM. So then, using the LLM, with the help of it, it creates a plan of action. So agent will create a plan. So the plan can be read this file, then write this to this file, then see if this is working, etc., etc. There can be a lot of things in this plan. So after this plan is created, the agent has this execution loop which keeps the track of the state of whether it should finish executing, it should finish its job or not, which can depend on a lot of things. The agent can ask the LLM itself to verify if the task has been finished, and if the LLM says okay, the task is completed, the agent can stop. There can be some hard coded stopping conditions as well. As for example, let's say we run an agent and the LLM never tells it that we have completed our job. The agent will just keep on making different more and more requests, so it will go into an infinite loop. So we also don't want that. So maybe we define a max iterations count, that after 10 iterations you just stop even whether the task is completed or not. So coming back to the plan, so it creates a plan, and according to the plan the agent executes the task with the help of LLM and with the help of the tools and the state. So state is just keeping a track of where we are in this plan. So if we don't have the state, every time we give a new prompt to the LLM, we will not know that we have already completed the tasks above over here, right? So we need to just keep track of where we are in our plan. So that is basically what the state is. But the main game changers over here, the things that differentiate an agent from just a single LLM, where LLM just takes in a prompt and gives a text output, are these tools. So tools are basically Python functions, or you can say any kind of a function or any kind of a way that lets the agent interact with the system it is in. So an agent might have a tool called read file, which might help the agent read the content of a file. An agent might have a tool called send email, that the agent can use to actually send an email to someone. So this is the thing that differentiates the agents from a simple LLM. Agents can use LLM for reasoning, but they can then also use the tools to actually complete some real world task instead of just giving you a text-based response back. Like just as we saw over here, the agent itself created a py.py file, and it read what was needed to be done from this empty file on its own. We just gave it a simple vague prompt. So this is the power of agent. So now enough of all this theoretical talk. Let's actually dive head first into coding. Let's create a simple agent of our own. In the last video we did create an agent. So what we'll do is, to save us some time, we'll not write all the code from scratch. So what I have done is I have just copied all the code from this agentic rag, the code that we saw in the last video, into this file. And what we'll do is we'll remove these embeddings and the files rag part, because this time we are not going to focus on rag. So to not make the setup more complicated than it needs to be, we'll remove all the unnecessary components. So now we have a very simple agent. So we are just importing the create agent. We are just loading in the .env file, because obviously we need the API key. We are creating a model and we are creating an agent with that model as the reasoning component of that agent. And then this code just calls that agent with a simple query. So now, as we saw just over here, the main thing that differentiates agents from LLMs are tools. So let's create some tools of our own. So what we'll do is we'll from LangChain.tools import tool. So from LangChain.tools we imported a tool. So just like in the last video you saw the dynamic prompt which was a decorator, this tool is also a decorator. So what that means is we can define a function, let's say create Python file, which will have the file name, the content, and it will return a string, and we'll give it a doc string about what the function does. So create a Python file with the given file name and the content. So what we do is try with open file name dot file as f, write content return true and set exception as e, return false. So what we did over here is we created a simple function called create Python file that creates a Python file and returns writes the content to it and returns true if the file was created and returns false if the file was not created. So now this is just a simple Python function. There is nothing new about this, but we can decorate it with the dash @tool decorator to make it a tool that our agent can use. And now you might be asking, okay, but how does the agent know what this tool does? So that is where the doc string and the annotations come in. So we have clearly defined that file name is a string, content is a string, and what it returns is also a string. So in this doc string, we can tell the LLM a lot more about what this function does. So we can say we omit the .py extension from the file name. So as was over here, as you can see, we are just using the file name and we are adding the .py ourselves. So that means if the model was to call this function with a .py file name like py.py, then the file would get created as py.py.py. We don't want that, right? So, but how would the agent know? So we have to write everything explicitly in the doc string. So we write this here and we also tell it that if the file is created successfully, return true, else it returns false. So now we have given all the info the agent would need about this function. And we will also need one more function that lets our agent read a Python file. So we can say def read file name. So what we do over here is try with open file name as f, return f.read, and otherwise we just return error reading the file. So now we can also give this doc string just like the previous function. Reads a file and returns the content. Gives the full file path with the extension this time, and yeah, we can just say this much. So now we have created, okay, we'll also need to decorate this as well with the tool decorator. So now we have created two simple Python functions which can read a file and create a Python file. So what we'll do is first we'll just delete. Actually, let's not delete this. So what we'll now do is we'll give these tools to our agent. So now when we are creating the agent, we'll give these tools to our agent. So now our agent will not only be able to provide us a text-based response, but it will also be able to use these tools whenever needed. It will smartly take the decision if it needs to use the tool or not. Like if we just ask it a simple prompt of what is the capital of France, it will not use the tools because it knows it can just answer that directly. But when it needs to use the tools, it will be able to. So what we'll do is I'll give it. So first of all, I'll just also copy this file in this folder because just to make it a little simpler for our agent, because the cursor agent is very complex. We are just making a very oversimplified agent compared to that. So it might be get confused with the path names if the files are in the different folders. So I just copied the same what I need .md to this folder as well, and we'll just copy this same prompt that we gave to cursor, and this time we'll give this to our function. Prompt is very long. We'll just divide this a little. Yeah. So make a Python file for me called py.py, and the requirements for that what the program should do are in the file what I need .md. So so this is our query. So the same query that we gave our cursor agent. So now instead of the cursor agent, let's run our own custom agent and let's see what it does. Okay, so as you can see, our model also created the py.py file. So it says that I have created the py.py file for you. It can print the first n digits of pi. So now as you can see, if we go to this Python file, it is actually different from what the Sonnet agent created. It also got created over here because I ran the program globally, and because of that the paths were also global. So this file is what got read instead of this, and because the function that we created, this one, the write create Python file function, it just opens it in W mode, it overwrites the py.py file. So as you can see, it created a function of a simple math program, and it just print n digits of pi using the math.py. So it used a different approach because it used a different LLM behind the scenes. Over here we used Claude for Sonnet, and over here we used the Gemini 2.5 Flash model. And like just to show you that this was created with our program and not the old file, actually let's change the file name. So let's call it print py digits.py and run the program again. So again, as you can see, it says that I have successfully created the Python program print py digits for you, and this is the program that it created. It again used the same logic, but I just did it again just to show you that it was created with our own agent and not this cursor. And again, as you can see in the prompt, we never mentioned anywhere that what the program print py digits needs to do and whether it defaults to 4 digits and all or not. It read all those requirements itself from this file, and then it itself created this Python file. So even though this coding agent is a super oversimplification of what is this cursor IDE can do, this is a good start to understanding what agents actually are. So as you can see in this, there were a lot more complicated things, like it asked us whether it should run the program itself and then test the output. So over here it did not ask us when creating this print py digits.py file, right? But there are ways using middleware that we can make these agent ask us questions or for permission before using certain tools and all. So we'll learn all about that and even more in the coming videos. But for today, let's stop over here. If you liked the video, don't forget to subscribe so you don't miss out on any agentic AI updates, and thanks for watching.